Okay, so the lesson today is actually a continuation of what I covered yesterday. Remember, yesterday we talked about graphing a line using what? One point and slope.
Oh, the anchor point.
Yeah, the anchor point. Very good. Today we are actually using the same technique, using one anchor point and a slope. But the trick is you have to recognize which one is the point and which one is the slope. So you have to identify. Here's the lessons. 4-3. Graphing using slope-intercept form. Okay, so now that we talk about slope-intercept, I have to first introduce you what does it look like. I want to say slope-intercept. The first thing you would recognize is that the slope-intercept form will have the output variable out in front. I have to specify this as an output because sometimes I can use a different letter for output. It doesn't necessarily have to be Y all the time. So I have to identify. So the output will always be out in front, isolated by itself. Okay, so it's going to be out by itself. And the next thing you'll see is I introduced to you this yesterday. What's the letter M stand for again?
Slope.
The slope itself. And the X is?
The X.
What do you think the X is?
The X-axis.
The input variable. Very good. And another letter I want to introduce today is the letter B. This is for the intercept. However, specifically, it is the Y-intercept, not X. Y-intercept. Okay. Let me ask you this question. Is the Y-intercept a point or is it some other thing? It is a point. So technically, don't you see that we have a point and a slope? That's enough for us to graph a line. And all you have to make sure is that you recognize the form and that you also see that the slope is always in front of what variable? More specifically, or should I say general, it's in front of the input variable, right? Or the independent. And of course, the output or the dependent variable is always by itself on one side. If I don't have this in this format, you've got to make sure that you have to rewrite it in this format before you identify your slope and your y-intercept. So let's pretend now that I already have it in the right format for you, so everything looks good. So pretend that I have this. Can you identify for me which one is the slope, which one is the intercept? Very good. So the first thing you pull out is your -2, and you say, okay, so my slope, I should just go ahead and write this for now. There you go. So you see the slope is M. And it's what? -2, and notice that why is it that I have to convert back to a fraction? Why? Because of the rise over run effect, right? Because the slope is described by rise over run, which is a fraction. So if I don't see a fraction for slope, I have to convert it back to a fraction. And this is how we convert a fraction. We put a 1 underneath the number. Done. So tell me, based on the rise over run effect of your slope, what do you do with the -2? Upward or downward? Down, because rise, but then it's negative, so you go down 2. So I put that arrow indicating that it's going to go down. And then what do I do with the 1 run? Right or left? What do you think? Right, because it's positive. So I know it's going to go right. Is there another way to write the slope? You can't switch it though, not like that. The slope is -2 over 1. Is there another way to write it? Okay, let's graph it first, and I'll explain it to you in a bit. So okay, so you identify your slope. Can you tell me what is this 3 doing? What is that 3? Thank you. So the 3 right here is the y-intercept, and let's use the letter B so you are familiar with it now. So B is your y-intercept, and it is 3. How do I write this as a point though? Okay, very careful. Okay, remember if it's a y-intercept, then x will always be 0. So therefore, the point is 0, 3. Okay, is that clear? If the y-intercept, x is always 0, right? Right? I give you the y-intercept, therefore the x is 0. So here, I make a graph. What is the first thing I'm going to plot?
Y-intercept.
The y-intercept. Good. So just like yesterday, I plot a point, but in this case, it's more specific. It is the y-intercept always. But it's actually helped you a lot because you know that the y-intercept will have to be on what axis all the time? The y-axis. So in this case, it's 0, 3, so you know it's going to be right here. Is that easy? Okay, how do I get to the second point? What does the slope tell me to do? Go down 2, so 1, 2, and run 1. So in this case, my second point is right here, isn't it? So technically, I can make the line at this point because I have 2 points. However, let's say that I want another point on the left-hand side of this. Is there no way to get another point on the left-hand side? Up to? Very good. Up to left 1. And notice, up to left 1 means it's going to be 2 over -1, isn't it? And that's exactly what I asked you. Is there another way to write the slope? Isn't -2 divided by 1 -2? Isn't 2 divided by -1 still -2? So I'm not changing it. However, by reversing the direction of your arrow, you will be able to achieve another point on the same line. Just in case, just in case you run out of space over here on the left-hand side and you want to go in the other direction, just reverse your slope. You see it? So take the opposite of the value. In this case, I have myself 3 points, and I can connect them to make my line. And that's how you graph a line using the slope-intercept format.
Can you make it straight?
No, I can't in this case, sorry. But are we clear on that? On how to graph using the slope-intercept format? And so yesterday was kind of the same idea. You missed yesterday's lessons. It's the same stuff, isn't it? Okay, any questions so far? Now let's just change this variation a little bit to see if you can actually still recognize it. What if I give you something like this? Yeah, there you go. What if I give you something like that? -2 times x plus 3 times y equals to -9. I asked myself, is that the slope-intercept form? No, it's not. So if it's not in slope-intercept form, how do we convert it back to the slope-intercept form? Okay, so before you say we're moving stuff around, what is it that you are targeting so that it's to be by itself on one side? Okay, or more generally, your output variable, right? So we know that y is generally your output variable because x comes before y and y is your output. Okay, so y. We're targeting y right there. If we want to make sure that y is going to be your end result like this, what do we need to move away? Okay, so the -2x and the 3. Notice that the -2x is that the entire term or just part of the term? The entire term, because it's separated by a plus, right? And the 3 is that a part or the whole term? Part. So we know that there's a whole term we have to get rid of. There's a part of the term we have to get rid of. Which one we have to get rid of first, though? The whole term. How do I move the -2x away? If we are moving the entire term over, how do I move it? There's only 2 operations, adding or subtracting. Never divide and multiply if you are moving the entire term. Okay, please remember that. So we are adding 2x over, and I have myself with this. Is that good? What's the next step? Very good, because now 3 is part of the term. I can get rid of 3. I do the opposite of that. 3 times y, so 3 divided by 3 both sides. But here's the thing that's very important, and remember. If you are going to be dividing on one side, you have to divide to every single term on the other side as well. Not just one. Every single term. Don't forget that. So what you end up with is 3 divided by 3 is 1, so you end up with y by itself, right? Over here, so you end up with 2/3 x, right? I don't want to divide this. Why? Because fraction here is your slope, right? And slope is good in fraction form, so leave it. What is -9 divided by 3?
3.
-3. So, is this in the right format that you want to look at? Yes, because it is y equal to m times x plus b. And you might argue, wait, this is a plus. No, it's fine. If you take this -3 and plug it in here, you'll make it a negative anyway, so it's okay. It's okay. It's a general format, so as long as you have what you're looking for, the m and the b, you're good to go. So, let's identify the slope. What is the slope?
2/3.
There you go. And the y-intercept right there, right? Okay, so how do I plot the y-intercept? Where is it going to be?
On the y-axis.
Okay, so where is it exactly?
Down 3.
Down 3, right here. What about the slope? What does the slope tell me to do?
Go up 2.
Go up 2.
And to the right 3.
Very good. Up 2, right 3. Up 2, right 3. So I ran out of space over here. What if I want to go the other direction? What else can I do?
Left 2, down 3.
Remember, rise over run, not run over rise. So you have to move up or down first before you can go left or right. So down 2,
3, right.
left. You got to do the opposite, right? Very good. So it's right here. And guess what? There's your line. Question. Is that easy? Okay, so I showed you the technique of if I give you a form that doesn't look like the slope-intercept form, you gotta make sure you put it back in the slope-intercept form before you start graphing. Identifying the slope, intercept, then graph. Okay. Now, I do have another variation to see if you can actually recognize it. It's going to be a quick process. Here we go. What if I give you something like this? How do I graph again? What's the first thing I'm going to plot? The y-intercept. Where's my y-intercept? Where is it? What's the value here?
0, -8.
Very good. Notice how I kind of switched this around? But is it still technically the slope-intercept format?
Yes.
Because even though it's not y equal to m times x plus b, I can still switch things, but you should recognize that the slope is always in front of the input variable, which is x. So I know that my y-intercept is right there, and my slope is right here, isn't it? So -2, I'm just going to go ahead and locate -2, and the slope tells me to do what? Go up 2 and right 1. Up 2, right 1. Or, what else can I do? So instead of going up, I go down 2 and left 1. Very good. So down 2, left 1. And you also have yourself a line. You see how that works? So either direction is fine. But just remember that if you have it one way, do the opposite to go the other direction. Last variation to the problem, and we are done for the day. Yes, absolutely. Let's do it right now. Oh, wait, you need to see it? Okay, all right. So look, what if I have the following? What is available? Yes, Matt. Ooh, how did you get that? No B. Very good. So you recognize that there is a slope, right? Which is in front of the input variable, x. The slope is right here, -3 what? Over 1. So you go where? Down 3, right 1. But then I realize that there's no anchor point. No B. So in this case, you need an anchor point. If there's no anchor point, we start at where? 0, always. So basically, if you see no anchor point, you just have a 0 for it. So that means the anchor point will start right there at the origin. See it? And then just go use your slope. Down 3, right 1, right here. So, how do I get another point to the left?
Go up 3.
Up 3?
And to the left 1.
Very good. And left 1. And you have yourself a line. Now, see how that works? Okay, is this difficult? And this is what you're doing today. Graphing. Okay? So please, if it's not in this format where the output variable is by itself on one side, you are not ready to graph at all. You got to make sure you have the variable by itself on one side, and we show you that technique to move stuff around. If you're moving the entire term, add or subtract it over. If you are getting rid of part of the term, you are dividing or multiplying. Okay? All right, so that's it. Let me just go ahead and get you started with this again.